Good morning, friends. Now today we are going to discuss about another relevant topic of casting, that is design of pattern. Design of pattern is very much important. The reason is that will lead to the appropriate formation of the cavity, and if the appropriate formation of the cavity is done, casting will be accurate, satisfactory, and if it is not done, definitely the casting will be rejected. So one has to take lot of care in order to do those kind of appropriate design in case of pattern. In many cases, the design of the pattern is not provided by the designer. Designers are interested about the final product, and the pattern making has to be designed by the people who are associated with pattern making, and they have to find it out what can be the right kind of pattern which will lead to the formation of the right kind of cavity, and that will lead to the right kind of product. Designers are interested about the product, so according to that they will specify those things, but the pattern makers or the design who are associated with design making of the pattern activity, they have to find it out the design, because that has to do some kind of strategy making in terms of the pattern to create those cavities to manufacture the appropriate product. So design of the patterns are important, and definitely the selection of the different availabilities of the pattern has to be there. So in the title slide one can easily see that there are different kind of pattern. One is one piece solid pattern, then the split patterns are there, then cope and drag formation which is used, then match plate pattern. So many such varieties depending upon the applications, because one thing always have to be kept in mind, that the pattern has to be removed from the sand casting. If we make a pattern which cannot be removed from the sand casting, the purpose is lost. Then where the molten metal will come into those cavities. But only in case of investment casting, one does not have to remove the pattern, because the pattern is melted away of elevated temperature. That is the advantage of investment casting, but problem is that every time we have to make a pattern, so that will be a sacrificial pattern based casting. So the different foundry patterns are there. There are different depending on the applications and tedious operation to the workers, some of the pattern making, and especially when translating a drawing into a pattern. Which drawing will lead to what kind of pattern and what will be the fine tuning is a tedious task, and the casting patterns cannot be escaped in order to carry out these operations. One cannot escape these tedious job of making the right kind of pattern, designing the right kind of pattern in order to have the right kind of product. So different types of casting patterns are used in the foundry shop, which are to be considered by the following choice of different castings, and there are number of castings to be produced. If we want to go for mass production, so one kind of strategy, and if we are going for the single piece or batch size of production, one kind of strategy in terms of use of pattern, and all sorts of things depends on the number of products have to be manufactured at the end of the day. So these are all controlling decisions related to the choice of the pattern and what type of operations after those casting and other things. So people will come out with the right kind of pattern, so that the right kind of product is produced with ease. So different patterns are there. The first one is a very simple one, single piece pattern. It is only created for those very less complicated and complex jobs, because it is easy to remove. So then and then only people go for the single piece pattern. Otherwise single piece pattern removal is always a challenge if it is associated with a very complex and complicated geometries of those cavities. And the second one is split piece pattern. So you split the pattern. Again, the main motivation here is in order to retrieve those patterns. So pattern is splitted so that it is easy to retrieve from the mold to create the appropriate cavity. And the splitting strategy all depends upon the complexities of the job, and people require a lot of expertise the gray hair people are associated with to decide about what kind of split patterns will be there in order to ensure the easy and defect-free withdrawal of the pattern from the mold. Then loose piece pattern, sometimes it is so complex that we have to use some loose piece here and there in order to create all those cavities. So loose piece patterns will be very suitable for those kind of cases. And the last one is the gated pattern, where gate formations and everything is done in the pattern, and where maybe say mass batch production will be done. So everything, the gate and everything is created in the pattern, so that one doesn't have to create all those channels and gates and those part of it related to those casting process. The fifth one is the match pattern or match plate pattern. So cope and drag formation, if I show the figures, the things will be clear, where one combination to others. The sixth one is sweep pattern, a strategy, one part and then it is rotated in order to generate the entire part of the pattern. With some symmetrical object, one can do the sweep pattern in order not to make the entire pattern, so make part of the pattern and then rotate it in order to create the appropriate cavity. Seventh is the very popular combinations of cope and drag configuration. That is very common and very fruitful in many of the castings. Then eighth one is in the formation of some kind of shell, so typical pattern is there. And the ninth one is the boat pattern, so that also have some applications. The first one is the single piece pattern. These types of foundry pattern are one of the simplest types, accommodated either in cope or drag fashion. It will be either in cope or drag. It is not splitted, so it is not divided in cope and drag. So it is a single one, and it is in large castings, stuffing box and other things of those steam engine and other things are made by that, and this pattern is exactly like the desired casting. So entire copy of those shape will be done, but definitely it has to be of a less complex, and it will be put either in the cope or in the drag. Then split pattern. Split patterns will be there, split along the different parting line, either at the flat or irregular surface to make easy extraction. The main motivation of the pattern is that to create appropriate cavity and associated with easy withdrawal from the mold itself. And that is why the split strategy is done, so that it can be withdrawn without much hassles, without any damage to the intricate surfaces of those cavities of complex casting. So that is the main activity related to those split patterns. So one can see from the figure itself, all those split patterns are creating those cavities, and in these cavities the molten metal is poured by the ladle. Then it is a multi-piece pattern, single piece pattern, and that way it is done in the molding sand. And sorry for this little spelling mistake in the title, it will be PIEEC, single multi-piece pattern. So different pieces are there, aligning pins and other things will be assembled together in order to form those multi-piece pattern. Then loose piece pattern. Loose piece patterns are where the things are complex and linking another part will be difficult. So people are using these kind of casting patterns. When a piece of solid pattern has a backdraft or projections, and which may be difficult to implement and sometimes difficult to withdraw and all those things, so people are using those loose piece patterns used when withdrawal is very difficult. I have already told you that the biggest problem associated with the pattern design is that easy withdrawal from the mold. So that is the first criteria, when withdrawal is extremely difficult and some obstructions of the part laid as a loose piece, and highly skilled job. Again, pattern making and pattern design and pattern choice is highly skilled job, because it is not done by the main design office. Only thing is that one has to make the pattern in order to get the right kind of object. The designers are mainly associated with the right kind of product, and the pattern making people has to decide about what kind of pattern will lead to the formation of the right kind of product and right kind of cavity. The next one is the gated pattern, through which we can make many of the part. Gated patterns, one or more loose patterns, and they are made it in one single piece, and you can generate some kind of mass production. Whatever you can see, these patterns, many patterns, they are repeated along the gate, the line, and entire thing is created so that it is easy to manufacture all those things in multiple number of cases, and it will be gated pattern where we have to go for the mass production. These kind of patterns is used, and once the casting is done in one go, definitely so many products in one batch then come out of it. So these kind of patterns are known as the gated pattern. The next one is the match plate pattern. This is also another type of casting pattern that is similar to split one, but having the cope and drag portions mounted on opposite sides of the plate, usually those plate and there, and which comply with the contour of the parting surfaces. So gates and runners are also mounted on the match plates. The advantage is that one doesn't have to make those channels of runners and all those things separately. So it is already done. So it is a very productive type of patterns, and this match plate is used for large number of castings, result to higher productivity. So many a time we can use it, and every time we don't have to go for cutting off of those gates and make those runners appropriately. It is a mass production, so this everything is done on that, and on the basis of that cope and drag formation, immediately we can do for those things for higher batch size production. One can see these match plate pattern. The casting is there, so that is the slitted one, and this pattern with some match plate which will ensure the proper location of that, and one can see these match plate pattern. The plates and all those things in the configuration, it will be matched together, and appropriately they will form the cope and drag formation. So that is done on the basis of those use of the molding in the cope and drag configuration. So the next class of pattern will be sweep pattern. These type of foundry patterns are used when large size castings are there. So we don't want to make large size of pattern, we want to make a small part of the pattern, and because of the symmetry we are rotating and all those things, sweeping in order to generate that kind of cavity. Clever way of generation of the cavity with a smaller part because of this symmetrical part of the cavity, and that is used, and casting is required to produce in short time, and it is a section or a wooden board proper contour that is rotated about the edge, and to shape the cavity having shapes of some rotational symmetry. Just from the photograph itself one can find it out. So one part only just a sectional part, and that is rotated, the sweep board rotated around a spindle and create the big cavities. So just a small section, and with the symmetry of rotation it has been created. So that is a very clever way, but only possible when we have the rotational symmetry of those products, and for those cavities are generated with a very small part of the pattern just rotating against the spindle. This is the sweep pattern of the sectional view. So one part is only there, and that is rotated, and on the basis of that the cavity will be prepared. The next one is the cope and drag pattern. This is another type of foundry pattern, very popular, similar to split pattern. And cope and drag, top part of the mold box is cope, and the bottom part is called the drag. So cope and drag configuration, each mounted separately on those match plate, and they are used in production of large castings. Its operation cannot be done by a single worker due to a very high big weight and unwieldiness of those molds and other parts. So sometimes it is a multiple person job, and with the use of some short cranes. You can see the cope and drag pattern. The one part is the cope. So the pattern is there, then on the basis of those mold block boxes are placed, and then the sand is put into that, then they would be properly rammed in order to form the cavity. Once the cavity is there, then with all sorts of steps, pattern is removed, and there is a top part of it, and then you create similarly the bottom part of it and put all those boxes, mold boxes in appropriate locating pin, and then the entire solid cavities and other things will be produced. The next one is the skeleton pattern. So when the skeletons and all those things made of those typical structures, and on the basis of that, apart to because it is large casting having some simple geometrical shapes used in peat and floor wooden processes, used for small number of large or heavy castings or ribbed construction. So on this basis of that, the pattern is assembled together on the basis of those scales, and the desired shape is obtained. And this is the strategies of the skeleton pattern. The next one is that the shell pattern. This type of patterns are produced in a mold, outline the shape of the part to be coated. So only those part is given. So typical type of shells and other things are there in order to make some very slightly complex hollow castings, and in order to that, the outline of the shape part has to be coated, and on the basis of that, these kind of shell patterns are used. Then another one, the variety follow board pattern. These types of foundry patterns are used as a device. It is used for various purpose of different board work, and wooden boards are used in order to generate those kind of pattern. One can see the follow board type of drag patterns and the follow board, and from there itself the pattern will be associated with, and according to that the product will be manufactured. So that's all for today's lecture. We have discussed about very detailed in terms of the classes of the different patterns, their withdrawal strategies, because withdrawal is the biggest problem of the pattern, to take out from those mold without rupturing, without jeopardizing the intricate shapes of that. So that is why people have designed many various things, innovative things, where the shapes are very simple, people are going for single piece pattern. Where the shapes are complex, people are going for all sorts of varieties. And whenever the clever variety is that sweep patterns, people are using when only the section of the pattern, and then it is rotational symmetry is utilized in order to generate all those symmetrical cavities, another part. And then people are going for the skeleton patterns for the last castings that will be assembled, and according to that the cavities and other things will be produced. And all sorts of strategies are been fixed up by the people who are associated with the pattern making shop, and the pattern making shops are also having some very experienced and skilled person who will decide about their experience, that what kind of object, what kind of pattern, and what kind of implementation of all those patterns will be there, so that the withdrawal and other things are very much possible, and according at the end of the day we able to create the appropriate cavity for the right kind of product as a whole. So different kind of skill based knowledge associated with those pattern making, because pattern making will lead to the appropriate formation of the cavity, which is associated with the precise, accurate mass production or single piece production of the different casting. Thank you.